Hello there guys, welcome back to another feedback video. Now, this is the end of years, so make sure that we are paying attention. We are doing our full corrections. We are adding full explanation, full calculation. Everything needs to be full properly, yeah? Now, the earlier you get this correctly done, and the easier it's going to be next year, and even more easier it's going to be when you get to year 11. Now, pretty much, you guys are pretty much almost year 10 now, okay? So we are towards the end of this academic year. We need to make sure that everything is sorted out. Now, equations, we need to remember them. We need to know how to use them. And then, of course, there are a few ideas in physics which we want to make sure we understand how the world works. Now, first of all, we need to remember, for this question, we need to remember that F is equal to ma. So force is equal to mass times acceleration. Now, we're looking for mass, so therefore, we have force on one side, stays force. Now, acceleration, we want to get rid of it, so we have to divide by acceleration. So this becomes force, which is 450 divided by 0.35. Now, make sure that we're using a calculator in this case to get our answer. Okay, so this is my answer in this case. Okay, now let's move to the next one. Now here we have a car, we have a journey, so motion, this graph. This is what we started looking from this September. The first question is complete the sentence. Complete the sentence. The car is traveling at constant velocity. Now, constant velocity means the velocity is not changing. So here, from here to here, we have constant velocity. How do we know it's constant? Because the line is flat at this point. So at this particular velocity, the line is flat. So the question says between what time? So it goes from 20 all the way till this point. So from 20 all the way till this point here. So therefore, the answer for this one is going to be 20 all the way till 45, because I can see it's between there 45. I'll count this. Okay. Now the next question is, using the data from the graph, calculate the total distance. So we need to show the total distance in 70 minutes. Now, first of all, we need to identify. I'm going to zoom in on this one because we need to know this. Okay, so this here is the area under the graph. So the area under the graph. Okay. Now, once we have identified the area under the graph, we can look at this and work out. Okay. Now, I'll make my life easier. I can see that the area have one shape here. So I'll call this shape 1. I have another shape here. I'll call this 2. Then I'll call this 3. So therefore, there are 3 areas I need to work on. So therefore, I'm going to look for area number 1, which is a triangle. So it's half times base times height equals. So the half is the half. Base is 20. Height, what's the height of this? So the height, it goes all the way to this point. Okay, and this point, I'll count this point as 15. So this is the one, 15. That's the first one. Now, second one is the area 2. So this is just the width. Okay, and the height. So the height, so length times width. So the length, okay, is 25. Why is it 25? Because from 20 all the way to 45. Okay, multiplied by 15, which is the height. Okay, and then we need to work out the area of number 3, which is another triangle. So half base height multiply, so half is half, multiplied by the base. Now we go from 45 all the way to 70. So therefore, what is the base in this case? So the base in this case again is going to be 25 in this case. Okay, and the height is the same, I believe, is this one. And then we just plug this in our calculator. So for the area of the triangle, the first one we got 150. The area of the rectangle we got 375. Okay. The last area we have this. So now what we need to do is we need to add them together. So therefore the area, the total distance, is going to be 1 plus 2 plus 3, so the area of all these three. Okay, so this and this and this. So we can take them together. Okay, and we're going to add them together. This will give me 712.5, and this is my answer. So this is what I need. I need to show that I'm getting this one, because the question says about. Okay, not exactly, not equal, about, and this is my answer in this case. Now, for those of you who got this wrong, this is what I need to see. Okay, so I need to see number 1, number 2, number 3, number 4, and then number 5, that you're getting this answer there. Okay, good. Now work out the average speed in this case for the whole journey. Now we wanted the whole journey, so average speed, you guys know speed is distance divided by time. Now the total distance, we know, if we already calculated it, is this much divided by time, which is 70, and the answer is 10.2, so I just write 10.2 there, and this is the answer. Okay, now if you get this wrong again, this is what I need to see. Have you written down the equation? Have you written down the answer? Now, even though, let's say, the distance, you couldn't calculate the distance, you could still have used this one. Okay, so all speed is equal to distance over time. So distance is there. We can use this one as well. So 1, this divided by 70. Okay, so we're gonna get 10.1. So this is also acceptable because it's given to you there. Now this is a good question, and we want to be able to do a few things. First of all, we need to work out the average speed. Okay, it's average speed. Okay, next we want to depend on height. So height, so this is the height. So what we want to do is we want to change this. We want to make this longer or shorter. So you want to talk about these things. Okay, all right, let's take a look. Now first of all, okay, first of all, what we're going to do, we're going to, using a ruler, okay, measure distance from x to y. So from x to y, this will give us the distance in this case. Okay, so distance. Okay, good, nice one. Now next one. Okay, so also using a ruler, we're going to measure the height h of the ramp. So what we're saying now is we're saying that we are using the equipment to obtain what we need to obtain. Okay, good. Now what's next? Okay, now we're gonna make my life easier. What I'm gonna say. Okay, so next will be the measurement of time. So using stopwatch. Right. Start. Stopwatch. Okay. When trolley passed X, and stopwatch when trolley passed Y. Okay, this gives the time taken to travel from X to Y. Okay, so therefore we're saying how the student is using the stopwatch. Okay, good. Now we said how the student is using the stopwatch. Okay. Okay, interesting. There's something that we need to do. Alright, so measure the height of the ramp. Okay, ramp. Okay, let's say what we're going to do now is going to measure the height of the ramp. Okay. Right. Okay. Let's go. Go. Using speed equal to distance divided by time to calculate the speed. Okay, so now what we've done is we said, okay, we're going to use the ruler. Okay, equal to, we'll use the ruler, use the stopwatch to do this to get the time. All right, so calculate, so measure the time to get the distance from this. Okay, all right, so this here is equal to distance traveled. Distance traveled. So this is what we need into our equation. Yeah, so we need this. So pretty much we need this time, and then we need this distance in this case. Okay. Now, what we're going to do is we are going to repeat the experiment. Okay. 3 times. Okay. Then take an average. Okay. Now, when we are going to repeat, okay, so repeat 3 times and take an average. Now, let me just rephrase this a little bit. Okay, so we are, let me change the color as well. We're going to repeat the experiment 3 times. Let me zoom in. At that particular height h. Okay. All right. So for example, if this is the height we measured at the start, okay. So we're going to repeat the experiment all, so 1, 2, 3, 3 times at that particular height, okay. 3 times, then take average. Okay, because so far, number 1, number 2, number 3, we are doing measuring the distance, the time, and then calculate the speed. So we do this 3 times at the same height, and then we take an average. So therefore, we get an average in this time. And then what we're going to do is we're going to repeat the above, okay, with different height h. So for example, so I, let's say at the start we have, let's say at the start, I don't know, we have 10 centimeters, and then we do 20 centimeters, and then we do 30 centimeters, and then we do 40 centimeters. Okay, now what we're showing is we're showing that we know what to use to find the distance, we know what to use to find the height, we know how to use the stopwatch, when to start, when to end, and then we're showing that we know how to work out the speed. We're showing that how to calculate the average speed, and then we're showing that we are how to get different results for different heights, which the question says depends on different heights. Okay, and this should be enough for me to get my 6 mark there. Okay, now make sure we understand what's happening here. We want to see, we want to show the distance, sorry, the average speed is affected by the height, because remember, the when you increase the height, when you make it steeper and steeper and steeper, you expect the speed to increase. So you need to say how you are measuring that. There's nothing to calculate, just saying how to measure and how to calculate. That's it. Right, so let's move to the next one. Now this one is centripetal force. Okay, now centripetal force, remember, if not, then here it is. It is a resultant force. Okay, points to center. So which of these, so which one, A, B, C, D point to the center? It is D that point to the center. Now, the ball is constant. Why is the velocity changing? Okay, now velocity is a vector quantity. A vector quantity has both magnitude plus direction. Okay, so the direction is changing. Okay, so since the direction is changing, therefore the velocity changes. So what's happening here, when the ball is going around, yeah, the ball is going around at the same speed. So for example, let's say the ball here, let's say if the ball were to be here, let's say the speed is, I don't know, 30 meters per second. When the ball goes to this side, 30 meters per second. When the ball gets to this side, 30 meters per second. Now, every single time in the circle, it is 30 meters per second. So the speed is the same. The question is, why is the velocity changing? The velocity is changing is because the direction changes. Now remember, the direction, okay, the direction is the speed. So therefore here, C is actually the velocity. Okay, so the velocity in the direction. Okay, alright, so that's one. Here we go. Now this one, we should know this one already. So what do we have? We have GPE, MGH. Alright, so we're arranging for H, so mg, go to H. We have 980 over mass. Okay, you just plug into yourself into your calculator. 2.8, 2.8. Again, you can actually see how easy it is to get 2 marks. Alright guys, okay. Okay. Now this one, we need to remember power is energy over time. Again, they're giving us free mark. So just put the numbers in. Okay. Now we need to be careful here because the answer we get is 1494 watts. Now the question says, I'm going to zoom in this case. The question says, give your answer to 2 significant figures. Now what we have is we have 1 significant figure, we have 2 significant figures. So therefore what we need to do, we need to put a line there. So we count 1, so this is the first one. Now the second one, which is the 4, yeah. Now if you look at the third one, what happened? The third one is greater than 5. So if the third one is greater than 5, means we need to increase the second one by 1. So this will be 5, this will be 0, 0. So therefore this is 2 SF. Okay, now we should have done significant figures in mathematics. Okay, so hopefully your teacher will sort you out over there, but this is the answer. Okay, so this will give you 2 marks, 2 ticks, and this will give you the last mark, what you need in this particular case. Okay, cool. Okay, so hopefully this will have helped you out. Again, we need to know how to get this done in the future. Now we have efficiency, another equation which we need to remember. So efficiency. Now efficiency, think of it of how useful are you? How useful are you? So it's going to be useful over the total energy. Now, if we want this in percentage, we're going to do it in percentage. But let me show you how to do it. So useful is this much. How do we know if it's useful? Look, 96,000 of energy is used. So therefore, this is the useful one. So therefore, here we go. This is the useful one. Now, what is the total? Look, it's supply. So it's giving this much. Therefore, this is the total. Okay. Now, you use a calculator. Right. So you're going to get 0.738. Now, if we want this in percentage, fair enough. So you can leave it in this form or in this form. The question doesn't say which form to leave it, so therefore it's up to you which form to leave it. Okay, nice one. Let's keep on moving. Okay, alright, so now this one's kinetic energy. Now we need to be careful with this one. So we need to remember, so kinetic energy is half mv squared. Yeah, there's a squared in the velocity, in the speed. Now we need to rearrange this. Now let me show you. So we have a half here. We get rid of it, so therefore it becomes divided by half. We get rid of the mass, divided by mass of v squared. Okay. Now we're going to take it easy. So what is the kinetic energy? Is 950 divided by half. What's the mass? 35. Now first of all, we do this on our calculator to make our life easy. Okay. So therefore we get 54 point, let's say 0.3. All we left now is do the square root. So therefore v is equal to square root of 54.3. This will give me 7 point 7.4. Let's keep it there. 7.4. Here we go. 7.4 is the answer. Alright. Now, if you got this wrong, here are the things that we need to see. And you need to see that as well. First of all, did we list down the equation? Fair enough. Second, did we rearrange it properly? Fair enough. Now, did we put the numbers in? Fair enough. And lastly, did we get the proper square root to get the proper answer in this particular case? Okay. Very good. So hopefully this would have helped you out in this case. Now, this is another question which we're going to do. Now, work done. So work done is force multiplied by the distance. Okay. Now the work done, the force is 1200 multiplied by the distance is this much. So all you're doing, guys, you just multiply the numbers together here. Okay, so you get 96. Okay. Now work done is energy, so therefore the unit is going to be joules. Yeah. So how much energy are you using in this case? So when you apply a force of this much, you move something. So how much energy are you giving it so it can move? So work done is energy. Again, if you got this wrong, make sure that you get this right for next time. Now, describe the energy transfers as a truck. Now, first of all, the truck moves. So therefore, we're going to have kinetic energy. So kinetic energy gets transferred into thermal. And this is the answer. Now, it is stopping. Why does it slow down? It's slowing down because of friction. Now, friction is a force, not energy. So be careful that when we're talking about this. Okay. Now, you guys should know this. Weight is mass times gravity. Mass is 90 times gravity is 10 on Earth. So therefore, 900 newtons. Therefore, the answer is C. Okay. Now, this question here, this is from your summative, so this is from your summative. This is from your summative, guys, you should know this already. Okay, so X is the waste energy. And how do we get this? So if this is the total, so let's do this. So if this is the total, goes in, we have this one, which is 950 plus x. So how much is x? So x is this, take away this, x is going to be 30. Okay, same thing, efficiency is useful divided by total. So useful is this much, total is this much, and then we plug it in our calculator, and then we get 0.97. So I'll say 97. Okay, this is a good question there. Now, if you got this wrong, make sure that you pay attention to this one properly. Okay, so make sure that you pay attention to this one properly, guys. If you got this wrong. Okay, now for this one, we're going to use the principal moment. So we're going to write down here principle of moments. Okay, now principal moment tell us that the total, now for the whole thing to be balanced, so balance, the total anti-clockwise moment must equal to the total clockwise moment. Okay, now this is our pivot. Okay, now the equation is force times d equal to force times d. Now the anti-clockwise moment is 120 times 1.3, because this is the anti-clockwise, because this is going down. And then the clockwise one is f, which we don't know, multiplied by 0.4. Okay, so therefore what we have now is we have the following. We have this equal to force times 0.4. So we got this divided by 0.4 equal to f. F is 390. Okay, this is what f is in this case. Good. So this brings us to this question there, and then we are pretty much almost there. Okay. Okay. Now, first of all, let's take a look at this one. So we want to work out how sound wave will use to work out the depth of the oceans. So this here is echolocation. All right. Now, let's sort this out. Okay, let's see what we have now. Okay. Now, first of all, it is ultrasound. We want to know what's going on. Okay. Now, the board okay, it will be the one that's going to make this sound wave. Okay, the board produces sound waves. Okay, all right, which travel through the sea. Okay, and get reflected off the ocean bed. Okay, now we're sending it. So what we're saying here, we're saying that it traveled through. It means it is emitted and then it gets reflected off. So therefore, if I draw it, we got a ship. Okay, so first it produces, it, and then send it down. Okay, so now we got the seabed, and once he hit the seabed, it's going to reflect back. So we need to say that it reflects back in this case. Okay, so reflect back. Okay, now the time taken between the emission and reception of the sound wave, okay, is measured. Okay, so it's measured by the boat, by a device on the boat. Okay, measured by the boat. Okay, now the speed of sound in water, we know. Okay, so we know this. So its speed of sound in water is about 1500 meters per second. So we know this. Okay, so we know this. So therefore, what we can do, okay, we can do distance is equal to speed multiplied by time divided by 2. Now we're dividing it by 2. Why are we dividing it by 2? That's just the question. Why are we dividing it by 2? Okay. All right. We need to divide it by 2. Okay. Due to one way distance. So we want to know one way because the wave is going twice, isn't it? It goes down and back. That's twice. We just need to know one way. How far is it? Okay, so that's all we want to know. Okay, so hopefully this makes sense. Otherwise, let me know if this doesn't make sense. I'll let your friend know. Now, this is another good question. Now, transverse wave, guys. Go on, we've done this before. Transverse waves, oscillations equal to perpendicular to direction of energy transfer. Okay, now let's get rid of the wrong one. Now, sound is wrong, sound is wrong, sound is wrong. Remember, sound is longitudinal. Okay, so by default, C is wrong, D is wrong. So we're left with 2. Oh, and A is wrong. So therefore, the only acceptable answer is B. Now, it doesn't matter. It doesn't matter if we don't know what infrared is. We don't know what ultraviolet is. We don't know. So all we know is sound is longitudinal. So therefore, by default, all the options with sound, they are crossed out automatically. Okay, so hopefully this helped you out. Now here we go. So this here, why is this the dangerous? Now there's only 2 possible answer for that. It doesn't harm human. Why does it not harm human? There's only 2 possible answer for that. First of all, so UVC equal to, so 100%. Look, 100% of it, okay, is absorbed by atmosphere. Okay, the reason why it's not harmful, even though it's more dangerous, because 100% of it is absorbed by the atmosphere. Okay, now UVC, okay, has the smallest wavelength. Okay, look at the wavelength compared to the other one. Okay, that's why. Now here we're looking for UBP, so which is and the shortest one. So therefore the wavelength is 2. So this is 2 nanometers. Okay. Now nanometers is 2 times power minus 9 nanometers. So therefore equation becomes frequency is equal to speed divided by wavelength. Okay, speed we know is given to us. Wavelength we know now. Okay, and this will give me an answer of about 1.1 power 15. So 1.1 power 15. Here we go. Fair enough. Okay. Okay. Now this one is from Summative. Okay, I'll put the link in the description below to direct you to the Summative, and it's going to be the video. It's going to be on 4 minutes 1 second. Okay. Now same thing for this one. So same thing for this one. So this is also your Summative. I'll put this there. This is also your Summative. Okay, Summative. Okay, and I'll put the video description below so you know how to get this correct. Again, so all this here is in Summative. Look, 8 marks from your Summative. If you revise your Summative properly, then you'll be fine. And the last question, now the question is, was this in your Summative? Let me have a quick check. Okay, no. Right, but we can still get this right. Now, acceleration is the gradient, which is the change y or change in x. Okay, now change y, first of all, is from here. Okay, so it's 4 minus 0 divided by change in x, which is 1.4. Okay, 1.4. So the answer is just divide them. Okay, and then we get your answer to be, there you go. Alright, so make sure that everything is fixed up. Okay, this is just working out there, and that's it. Everything needs to be fixed up properly, guys. Okay, we need to know what we don't know so we can make the future easy. Okay, and the good thing is, if you start now, then next year is going to be easy, and the year after will be easy. Okay, so ask yourself, what can you do now to make the future easy? And I've told you already. Now you just need to walk. Okay, show me you can walk.